Hello everyone, in this video we're going to see the solution to the Codeforces problem B TMT document of round 715 division 2. So I really like this problem, so I thought I would make a video on this before moving on to C. So the student council has a shared document file. Every day some members of the student council write the sequence TMT in it. I don't know why they put so much storyline into it, but yeah. So one day the members somehow enter the sequence into the document at the same time, creating a jumbled mess. Therefore, it is this person's task to figure out whether the document has malfunctioned. So here onwards we have our actual question. Specifically, he is given a string of length n and the characters in it are either t or m, and he wants to figure out if it is possible to partition it into some number of disjoint subsequences, all of which are equal to TMT. That is, each character of the string should belong to exactly one of the subsequence. So you should know what a subsequence is, but if you don't, a string A is a subsequence of a string B if A can be obtained from B by deletion of several, possibly 0 characters. Okay. So we have to say yes or no. Yes if it can be divided into subsequence and each of those subsequences is TMT. No if it cannot be. Okay. So let's take a look at the test cases. So the first test case we have is pretty simple, TMT. So this is TMT itself, so we don't need to do anything in it. And then we have MTT, right? So MTT. So in MTT, can we make TMT with it? No, right? We cannot make TMT with it. There is no subsequence here which is TMT. So answer will be no. Quite simple. Now let's take this test case. So we have TM, this thing, right? Now let's look at this. Can we make two TMT out of this? Two subsequence which are TMT out of this? Yes. How? Let's see. So I take this character, I take this character, and then I take this character, and I find one TMT. This is one subsequence, right? So I find one TMT using this, these two, and this last one. And then there's another TMT here. So I'm able to make it into two subsequences, both of which are TMT, right? And so the answer will be yes for this. So this is what we have to do. We are given the string, and we have to say whether we can divide it into two subsequences, both of which are TMT. And then we have another example. We have TM, this thing, okay? So here, this will obviously not be yes. This will obviously give no. Why? Because we don't have enough m to match the t's, right? And then we have TT again. So TT. Now let's check this. So can I form two subsequence, both of which are TMT? So I can use this T, then this M, then this T to find one TMT, then I can use this M, then this M, and then this T to make another subsequence. So I can make two subsequence, both of which are TMT from this. Okay, so this is how it's working. Now first thing, let's get out of the way. If so first thing is if the number of T is equal to twice number of m, only then we do the rest of our operations, right? Else the answer will be straight up be no, because there's not enough m or there's not enough t or there's some technical issue, right? And the number of t and number of m are just not enough, right? So first thing is we have to make sure that the number of t is equal to twice the number of m, and only then we'll do anything else. Otherwise we'll straight up say, hey, the answer is no. Now after getting this out of the way, let's see. So there's a bit of symmetry in this problem, right? So we have TMT. So we have TMT, this bit of symmetry. We have some T, we have some M, and then we have some T. Okay, that shows me one thing. So suppose I have MTT or I have TTM. Both of these are not correct, right? Why? Because they have M at the end. This has M at the left end, this has M at the right end. So in a way, I can think that there should be t's at the end, right? There should not be m at the end. And let's take another example. So let's work with this itself. So we have TT, right? So I have TT. So this works. Now I have a T, I have a M, I have a T, I have a M, I have two T's, right? So the number of T and the number of M here are equal. Now let's take another test case. Suppose I have T, M, T, right? So technically the number of T's are twice the number of M, but is this correct? No, this is not correct. Why? Because I have a T, I have a M, I have T, but this then M at the beginning of another subsequence. So that gives me a kind of intuition or kind of a thought that the number of t's, should be greater than the number of m at both end. Okay, this is necessary at both ends, right? So you may not understand this, but as soon as we look at it through code wise, you'll get it. So let's look at it through code. So what I'm saying is I'll traverse through my string. I'm traversing through my string, okay, and then I'm checking each character. So if my string of I is t, and I have a counter, okay, I have a counter for checking which is greater, right? So that's what we usually do. So I have a counter. So if count is equal to 0, initially it's 0. So if string I is equal to t, so count plus plus, and else count minus minus, okay. So if I'm finding t, I'm saying count plus plus. If I'm finding m, I'm saying count minus minus. Now at any point, if count is less than 0, then simply break out of the loop. Our answer is no. Just end the code there. Why? Because the count is less than 0, meaning that we have found the number of m is greater than the number of t, which is like this case, t, mm, t, 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 right? So we cannot find anything like that, okay? And so the answer is no. But if the count stayed greater than 0 or equal to 0 throughout the string, then we need to do something else. We need to reverse the string and then do the same check again. Why? Because like I said, the number of t should be greater than the number of m's at both ends. This is necessary. This is important. Okay. So why do I say that? So I have ttm and I have mtt. So mtt will get that m is less than count will become minus 1, but here count will not become minus 1. This is not correct, right? So we have to reverse this. It will become mtt, and then we'll run the same code again. So reverse the string, run the same code snippet, okay? And after that, if still you do not see any situation where count is less than 0, so you reverse the string again, you initiate count to 0, and again you run a for loop, okay? And then if you found count less than 0, then you say no, otherwise the answer will be yes, okay? So this was the pseudocode in a nutshell. What I'm doing is first I'm checking that the number of t should be twice the number of m, then I'm checking that the number of t's should be greater than the number of m's at both ends. For that I have for loop, and I have this counter. If counter gets less than 0, meaning that the number of m's have exceeded the number of t, then to check from the other end, I'm reversing the string, and then I'm running this same code snippet again. Now let's go to my actual code. I'll give a link to it in the description and you can look at it. Yeah, so this is my code. So like I said, I have t is equal to 0, m is equal to 0, and I'm counting t and m. If t is not equal to twice m, then the answer is straight up no. Else, I have flag is equal to 0. If I find t, count plus plus, else count minus minus. At any point, if count is less than 0, flag is equal to 1, break. And if flag is 1, then no. Else, reverse the string, run the same code snippet again. If f of I is equal to t, count plus plus, else count minus minus. If count is less than 0, flag is equal to 1. Flag is equal to 1, then no, it cannot be divided. If it is yes, then yes, it can be divided. Okay, so that's it. If you have any doubts, then just put them in the comments. I'll be sure to answer. Thank you.